that. So Steve, if you would like, go ahead and start your presentation. You had something going, right, Steve? You want to get it done and out. You're muted right now. You're muted, yeah.
Okay.
There you go.
That came up. Can you see that okay?
Not yet.
Not seeing anything yet.
Everybody see it?
We see you.
Just you.
All you see is me?
Yeah.
Yeah.
Did you hit share screen? You got up
I
there?
do, and then my screen shows only me, my presentation. Oh, escape out of it. What do you see now?
You?
All right, let's share screen again.
We
Hold
see
on.
everybody.
Now what do you see?
It's
It's
starting.
starting. It looks like you're gonna come up, okay. Well, it says you started screen sharing, it's back.
There we go.
There you go.
All right, now when you see it okay?
Yeah, you might want to, there you go. Full screen. Great.
Well, the topic is considerations in lighting structures, and we're going to cover the issues related to wiring, selection of bulbs, some installation tips, and control. And so with that, we'll just kind of move ahead and so on. So why would you want to light structures? Well, it kind of creates a little bit of wow factor, lots of sparkle, and gives a good, somebody come and look at your operation and gives a good first impression and so on. But it can be overdone, in some cases not too realistic, and could be distracting. Most buildings, even the daylight, have lights illuminated. And so if you look at buildings, you can see into them some. It allows you to create the impression that something's actually happening inside the building. In fact, you can make a interesting focal point with doing this. And if you do any night operations, where you turn the lights down and like to see the railroad run, it's really nice to have lighted buildings. And of course, doing this, just a lot of fun. That's what railroading's all about. Well, there seems to be a lot of interest in lighting things. If you, I don't know if any of you bought the structures that Menards build. I haven't, but you know, they really advertise this number of LEDs. They got them laid all over the place, some up here and there and inside and so forth. So they obviously think that's a sales point for them. You got Woodland Scenics has come out with this thing called Just Plug System, which is supposed to simplify and make it easier. We got somebody who's got needs a mute. I don't know who it is. At least I'm getting some really serious
Yeah,
feedback.
if everybody could mute, I'd appreciate that.
There we go. I think it took care of the problem. Anyway, this system's out there and it's getting a lot of exposure. And in fact, there's a recent article, I think, in the National Motor Radio Association magazine on how to use this system in a project. There's another company that's got a full page ad, I think, in Model Railroader called Model Train Technologies. They have a lighting system that they're pushing. And so there's a lot of interest in that. There are key components to it, and I'm going to briefly touch on all these. Power source, where do you get your power distribution system, the lights themselves, and the control system, and making things work the way you'd like them to. And we'll get more depth in each of those. The power source, I'm only going to look at LEDs, okay? Some of you may still use little incandescents, but I do not. And so maybe some of this won't be relate to you, but LEDs need direct current, okay? And so if your source of power is AC, you need to convert that to DC, and most of us have AC come in the house, and so you're going to have to buy something that makes that conversion. And turnkey systems like Menards and Woodland Cynics, et cetera, they sell stuff that's tailored to their system. For do-it-yourself projects, there are a lot of good options available. We'll look at some of those as well. But most of your power supplies are referred to as switching type, as opposed to transformer and the old transformer type. They're more efficient and run cooler and so on. And so you're going to find that most of them today, they're sold. All your wall warts, et cetera, are switching type conversions. Here's some examples of the stuff sold by Menards. They run at 4.5 volts, 2 amps, and that's a $10 fee for that. Woodland Scenics is a 24 volt system, $20 for their power supply, and Model Train Technologies, they run at 18 volts. So it'd be nice if they were all consistent and interchangeable, but they aren't, and the power supply are going to cost you that. For us do-it-yourself ones, you can go to a lot of sources. You can go to Amazon or eBay. I run 12 volt on my system. You can buy them anywhere from a couple amps on up to 8 or 10. Each time you go up on an amp or so, it's going to cost you about $1. I bought a 5 amp one on eBay, shipped to my house for $12, and that's installed underneath my railroad. So once you got the power, you either get it out to where you're going to use it. And again, the turnkey people make it easier. They have connectors with power cables and distribution hubs. So all the connectors are standard. You don't have to do any wiring. You just plug them in and so on. Makes life a lot easier. And some of these hubs that they plug into have control features on them, such as you can change the intensity of the lights and so forth in terms of them. And some are very sophisticated. We'll talk about that a little bit more. Do-it-yourself system is you're going to have to build your own network in terms of that. But again, that's part of the fun. Here's Menards. You can buy their package, and you can see the plugs, and they're all kind of standardized in terms of that. That little package gives you quite a few options, $10. Woodland Scenics light hub, that's a $16 one. Again, you can see the dimmer controls they have there. And then you got to buy the interconnections beyond those, and they're $16 on that. Model Train Technology is a whole different ball game. They have a 16-port box, and that's $85, but it has a lot of capabilities. And I'll get back a little later on talking about that. And their connectors are about $4 each. And for your do-it-yourself guys, you're gonna have to buy some wire, some terminal strips, do some soldering and so on. And so you can get going really well for $30, but it depends how elaborate you want to make it. It can go up from there. Lights. If you got the power, you got the wiring in there, and you need some lights. And again, we're only going to deal with light emitting diodes, which are referred to as LEDs. LEDs have some very unique characteristics. One is they only run on DC. They're very efficient, very low current draw. They have very long life, and so you don't often have to replace them. And the output is influenced by current flow. Now, this is an important point. To make them brighter or less bright, you got to change the amount of current flowing through the LED. Unlike an incandescent bulb, where you can have a dimmer on those, and in this case, you're influence the voltage level. As you move the voltage up and down, the bulbs get brighter or less bright. But LEDs, it's the current flow that's important. And again, I want to be talking about LEDs. Well, here's some examples of some LEDs. And you got the dime here to give you some indication of the size. The 5 millimeter and 3 millimeter, these are pretty common in the early days in terms of projects, and you can still use those, and they're fine. In fact, I just bought a singling light, and they're using 3 millimeter LEDs in terms of those. But these are the ones when people are using more and more today. They're surface mounted LEDs, and they come by numbers. The numbers actually mean something. For example, the 3430 indicates that's 34 millimeters long and 30 millimeters wide, and that's the size of them. So you get this one over here. This is like, for you guys N-scalers out there, that's a pretty darn small bulb, and it kicks out a lot of light even for its size in terms of, okay. Well, let's look at a very common LED, a 3528, and they come in different colors, and we'll talk more about what that. We're going to look at a bright white, which runs at 4,500 Kelvin. I'll talk more about what that means in a little bit. The size and actual size is actually a little bit bigger than what it says up here, okay? Because this is the size of the output itself. This is the size and when it's mounted in the case that it sets in. Some of these numbers are important. Peak forward current is a 0.05 amp, and they usually state that in milliamps, but I convert them to amps for you because it might make it easier. And you go past that number, you got a LED that doesn't do anything. So keep that in mind, okay? But they typically run that quite a bit less than that. They recommend the typical forward current that would run at is 0.02 amps. And that LED will disperse about 0.1 watt, which is important when you think about resistors, okay? And the minimum forward voltage, this is the amount of voltage it takes to get the LED to actually light. Until you reach that point, it's not going to do anything. And it's 3 volt, and that number is going to be used a little bit later on. And for that particular LED, the dispersion angle, the angle at which the light comes out, is 120 degrees. And we're going to look at all those numbers as we go along. Now, here's a good old basic law, Ohm's law. I'm sure you've all heard that in terms of it. But this one's the way it's generally stated. But if you do the algebra, you can rearrange it. And this is the one we're going to actually use, this rearranged here, where I is actually in current. I don't know why they didn't put C, but that's all right. I is in current, V is in voltage, and R is resistance, okay? So we're going to look at that 3528 LED, and the typical forward current is 0.2, and the minimum forward voltage is 30. And in my case, I use a 12 volt source. So how to make sure that the right amount of current flows through that, how big of resistors are we going to need to make sure that only 0.02 amps flow through that? So we're going to start with a 12 volt, and we're going to take away the 3 because the LED is going to get rid of 3 volts to be activated. So we're going to subtract that off and divide it by the current that LED runs at, 0.02, and that says we would need a resistor of 450 ohms. Well, nobody makes a 450. They make a 470. But that's awful close to being right on the margin. So almost everybody in this environment would move up to a 680, which is another common size resistor for controlling the flow that goes through that. All right. Any questions on this part? Yeah. I shouldn't have asked that because you're all muted. I didn't want to do that. So resistor sources and size, they're really cheap, frankly. Most people keep a little supply of them, 680, 1,000, 1,500, and 2,200 if you're running 12 volts in terms of that. And that allow you by substituting those, the higher you go up, the less intense the light will be that comes out. And you can, again, buy 10 of those on eBay, shipped to your house, 5% accuracy for $2.50. And if you got Amazon and your Amazon Prime, you can get the same sort of thing in terms of that. So. But sometimes people don't want to fool around with that, and they buy PC mounted LEDs, and that's LEDs that are mounted on a PC board, and you have both the LED, okay, and the resistor yourself. So here's your 35, 25, or 28, and here's your dime, not very big. Now this resistor is for 12 volt, they're using 1,000 ohm, and which is a pretty common resistor used on and controlling LEDs on railroads, because even inside of a locomotive, you're looking at 12 to 14 volts. That same resistor would probably be used. Now this one is a little different. This is a little board. Actually, this thing comes on a bar. I bought that about 5 years ago, and I think there's about 25 of these in 3 LED lights. So they're going to run in series. Now you hear people say, Oh, that's bad. If one of them burns out, they all go out. Yep. So keep that in mind. If you're going to put it someplace and it's almost impossible to replace it, maybe you won't want to use that. But they're pretty handy, and I have never had one burn out at this point. And the resistor here is only 150. And the reason for that is you got the 12 volts less 3, another 3 less 3. And so to control the flow, you only needs 150 ohm resistor. Okay. Now, LEDs come in different colors. And why is this important? If you guys are modeling in the 1950s or earlier, you didn't have a whole lot of what I would call fluorescent lights around and so forth. So you want to think about having LEDs. They're down in this area, 300K, which is your, or 3000K, which is your measure of how intensely the color is in terms of that. So over here, you can see 100 watt incandescent bulb is at 2800K, okay? A fluorescent bulb is about 4500 K in terms of that. And so you're going to, with that, and you want to be up in this area, maybe a bright white, but they get, a lot of your LEDs actually run up here in what's called the cool white, and that's almost a blue color that comes out. You see it as that color. And personally, I think it's, and this is a personal preference, I think it's not very real in terms, because even daylight is way down below that. So, but anyway, when you're buying LEDs, think about what color you want to be at, because your railroad may be back in this time period, and you want to look at some of the warm white or even golden white in terms of LEDs that would work for you. Now, can you do something if you got one of these cool whites? Can you do something about it? I read an article where you can use a, and I forget the brand name, but you use what's called a translucent orange paint, and you put over that, and you can bring it right back to look like warm white. So there's ways of adjusting. I have not done that, but I'm going to do that shortly because I got some lights I think they're too blue for me.
Steve?
Yep.
Yeah, that's Tamiya. The Tamiya colors are translucent, and you can dip them in Tamiya and put an orange glow to a blue-white LED.
Okay, Tamiya is the one. Okay.
Yeah.
So, and you had good experience?
Yeah, they work really well. You just have to, you want to control how much you dip in there. I dip them in, stick them in styrofoam, let them dry, then take a look at the brilliance. If I want to tone it down, I'll dip it again.
Okay.
Yeah.
So
Steve, I got a question about the color.
Yep.
Back when I used to fly a lot more, I always noticed coming in at night that the lights that you'd see on the ground, and we're talking like, freeway lights and parking lot lights and people's houses and stuff like that, there were always two different colors. There was like a greenish color and there was like an orangish color. And I think the greenish, somebody told me it was like sodium vapor lamps. And I don't know what the other one was, but I don't think either one of them were your standard tungsten light bulb type colors. Does somebody have LEDs, or is there a particular color that you can pick that would match those two?
Well, I should have commented. You see these labels here that I put these on there.
Some
They were cool white and daylight white, bright white, and center.
Yep.
You'll find bulb companies in particular will use those things and totally unrelated to what the competitor might be. And so the answer is you're going to have to do experimentation to find what you want, because
Right.
if you buy bulbs from Sylvania, for example, as opposed to GE, what they say they'll be entirely different in terms of what they really are. So you're gonna have to do some experimenting on that. But there are some colors out there you're probably not going to get in LEDs, such as that green color that you referred to.
someone had said that if you put like an orange pillbox over it, that gets closer to an incandescent bulb. I've never tried it, but I've saved a lot of containers. Walmart doesn't use them anymore, but
Yep, and I've heard that also. But now you got that pill bottle. Where are you going to hide that inside your building? So,
Hey, Steve, I've got one tip for Kevin.
Okay.
I know this is going to sound weird, but it works. I've actually used a Sharpie to change the color of a bright white to be blue, actually. So instead of changing the LED, I just used a blue Sharpie, covered it, colored it, and now I got a blue LED without changing it.
All
Okay.
right, so you can try experiments with different colored Sharpies to see if you can get the orange and the green.
Yeah, 'cause you go to a craft store or like Office Max, they got about every color of Sharpie under the sun. So
I
There you
think
go.
we got a set of those here.
But anyway, think about what color you want, because if you're doing stuff in the early 1900s, you're not going to need very many cool whites. Let's put it that way. Okay. And then you also need to look at dispersion. The 3 and 5 nanometer LEDs I showed you earlier, they have a pretty narrow focus in terms of where the light comes out. Whereas the T3528 we've been talking about, it runs at 120 degrees. And this is a little chart I've made. If you're two inches away from your light source, in terms of that 3528, it's going to cover out there 6.5 inches wide. Whereas another LED may only give you less than a couple inches in terms of it. So if you need a quick coverage of things, you probably want to use one that has a very wide dispersion of the light. Okay. All right, let's go on to a project. You probably bored you to death at this point. So we have the power supply. You've wired your distribution system. You got a bunch of bulbs available. So let's light up a structure. Now, in my case, I have a piece of real estate that's in a pie shape, and I can't get any siding in there and so on, but it's big enough. I just don't want to make it look like trees or woods or grass. And so I want to stick a building in there. So this is a Pike Stuff multi-purpose building. So they make nice kits, actually, particularly for filling up spots and so on. And I'm going to have to kit bash it because it doesn't quite fit with what I want to use it for. And it comes the way you see it. That's the blue plastic and so forth. And we're going to light that thing up as I would like to use it in my particular situation. Now, light a little bit like water. If it can find a way of getting out of it, it will. And so if I had just put some lights inside this building and turn the lights down and turn it on, it would look like a Kmart blue light special. I mean, it would really glow. So you got to make sure the light doesn't get out. And so you paint the inside walls black. And if you're using plastic, Terry will vouch for this, plastic doesn't do well with acrylic paints on it. So you're probably going to need I use a spray can, a black flat, and give my first coat of that. And then I give it 2 more coats of acrylic on top of that, because it's a lot easier to put too much on now than it is try to go back and correct it later. And then since it's inside and people might be able to look inside, eventually you're going to paint over what color you like on the inside walls. And I just use a pretty bland gray in this particular case. Well, here we got the walls up and center, and they're all painted. And here's the kit bash, and I put an office off the side. I had some leftover parts I could add to that. And here's what I've installed in there. I've used 3 of those 2 of those 3 light strips you see here. And I used one of those LEDs that's mounted on the PC here, and this in the office. And wire is 30 gauge. And I connect them to a lug terminal strip that I can solder them all together. Those that did some old electronic projects, these things are quite handy, and you can still buy them, but they're getting harder and harder to find. But it's an easy way to bring a lot of wires together and get them all hooked together in terms of that. This is what it looks like when I turn the lights on. Lights it up pretty nice. Now, the question is, how do I, when I put that building in place, how am I going to hook it to the wiring that's underneath? Well, drop the wires down and solder them in place. But I'd like to be able to take that building off sometime and maybe do some maintenance work or change some things. And so I use a connector. These are, you can buy these on DigiKey or elsewhere, but they're defined as 43mm pin and receiver strips. And so they're quite small. And so in my case, I only need 2 wires. And so I cut off 2 of these, just cut them off. Then I cut it off this with a razor saw, but you cut them off with a sharp knife as well. And likewise, 2 of the pins here, solder the wires on. And so when I put those underneath the thing, when I want to lift the building off, I just lift it up and unconnect this. And so it's easy to do that. And then get this thing down through the plywood with a 1/4-inch hole. So don't take a lot of space to do that. And these things are quite cheap. I think this thing was $4. So you're looking at 20 cents for a pair of pins type thing. So they're handy. Now, if you don't want to do that, here's another method. And I don't know that I'm going to use that very much for. These are 3 phosphorus bras strips I made, and glued them to the inside. This is the inside of a small depot. And then below that on the plywood, I put 3 screw connectors to that. And when you put the depot down on it, these fingers touch these things and you line it up. So you just pick it up, set them down, and then I don't have to worry about going below the thing to do that. This is more sensitive in terms of how they work, with the possibility. And so now I got my building installed, and this is a daylight scene. And so you see the building without any lights. And now you see the building with the lights on. And to me, it gives you the impression that things are going on in that building, whereas this one just looks like not much is going on in terms of it. Here's another view of that in terms of the building and so on. You can look inside, you can see some sparrows and so on in terms of this. What I made it into is a truck and diesel repair service. And if you look carefully, you can actually see inside the office, there's a desk there. It's a person sat behind the desk. There's a poster on the back wall of a Kenworth truck of the 1970 time period, and a guy talking to the guy behind the desk and so on. So there's things in there. Although my little camera seems to always want to focus on the outside, I couldn't get to focus on the inside. But it looks like there's things going on in terms of that. And here it looks at it in the night. Well, here you can see the inside. You can see some of the things in terms of that night scene in terms of the building. Now here's that depot that's set on the layout with the fingers. This is daylight scene, no lights. Okay, and here is a daylight with a scene, and here you see the station master. And over inside here is a lady sitting on the bench with waiting for the train and so forth. So it gives you an opportunity to show off some things that you'd like to do and make it more interesting. And here's the depot at night and so forth, and with a parking light and so on. Now, one of the things about this that I do, I actually have a bus line for daylight and I have a bus line for night. And so I don't particularly like seeing things turned on. For example, it really kind of takes away from it, seeing street lights on in the daytime, okay? And likewise, there's an LED in here, a small one, and that lights up the overhang of the roof here, where in the daytime it doesn't light. So you can set this up so that you got lights that turn on at night that wouldn't be turning on in the daytime. Now let's talk a little bit about control systems. Your turnkey system's got things for you. Woodland Scenic's got a thing called sequencing light hub, and you can program that to make the lights go on and off. And again, you control the dimming and so on, and how fast the sequencing goes and so on. So they bring that to you. Now, this one's really kind of interesting, the model train technology with its 16 ports. That one is such that you can hook it up to your DCC, and every one of those 16 ports you can independently program by changing CVs. And so you can have one that'll turn on and then stay on for 10 minutes and turn off. And another one can be flicker like it's a fluorescent light and so on. And another one could be making it look like as a welder's going. And so they're all programmable. And you do that by changing CVs. And then when you get it all programmed, you don't want to use the power of your track. You can disconnect it and plug in the power supply, and it runs off the power supply. And if I recall, that's a 16-volt power supply. So it's pretty specialized, but that's an $80 piece of hardware for you. Now this is one Andy put me on, and this is addressable LEDs that have actually 3 LEDs, RGBs, red, green, and blue. And you can control every one of those. And so you can make it as bright as you like, and you can any color you like, and so forth. And but you do that, you got to drive them with a computer. And so you can see here, well, you can't see until I move the cursor. This is what's called the data bus. Comes in and feeds the next one, and if instruction relates to it, it executes it. If it doesn't, it passes it on. And here's your voltage lines, 5 volts in the ground, and so they're all linked together. And if you like to do programming and so on, particularly you have a city scene, for example, where you have a lot of buildings and lights used for different purposes, and might be on and some of them on and some are off. This is an opportunity for you, and there's some stuff out there on the web that tells you how to program that to do that. And it's another way of controlling it. This is another little one. It's not very expensive. I don't know if anybody's experimented. I'm in the process of doing that. It's the LCEs lighted. And if you notice, there are actually 4 ports here, and actually 3 plus the ground. And you could again using either CVs, or you can use actually your throttle to turn these things on and off in the building, but it can only run one LED at a time in terms of it. So, but it has some potential in terms of being able to light some things up if you really want to control it. So, well, sort of in summary, putting lights in structure is not that difficult, but it can add a little bit of wow factor to your railroad, and it's really fun to kind of do it and see what the results are when you get done. So, thanks for your attention.
Excellent, Steve. Thank you very much. Does anybody have any questions for Steve? Steve, you're going to be leaving us, right? You have something else going on?
We all got a football game to go on sometime.
Oh, I thought you had something else sooner.
No.
Okay. All right. Good then. Anybody
Andy,
have any questions for Steve?
Yeah, I have something here. Let me share my screen here. Let's see. Share. How do I do that?
Oh, we got it.
Screen.
We're looking at you holding up a can of paint.
Yeah, that's it. That's that Tamiya paint. And a bottle of this will be a lifetime supply for anybody coloring LEDs, I would think. It's stock number X26, and they call it clear orange. So that's the stuff you want to use to color LEDs if you want to warm them down from a cool white to a warm.
Steve, that train technology little gray box that you showed, how difficult is that to program? Do you plug it into your laptop or?
No, you program. Don't think it has an option to plug into the laptop at all, David. You program that by using your throttle to send CVs to it. Okay, if you have a NCE throttle, for example, you can go into the program and it'll ask you if you want to send the CV value, and you say yes, and I don't remember it's a number 1 or number 2. And then it'll ask you for the CV number, okay, and then it'll ask you for what the value is, and that's of course after you selected what accessory you're trying to program in terms of that. But that's how you could program it. I think probably I don't know. I bet you Decoder Pro probably has a special option. You can do it through Decoder Pro very easily as well. In that case, you would be using a computer. Okay.
Yeah, would that be online with NCE in terms of instructions, or come with it in terms of?
No, then what the instruction would be with the box when you buy the box from
Yeah, that's what I mean. Yeah.
Yeah.
Okay.
from Model Train Technology. I don't own one. It's I'm doing your do-it-yourself guy, and so I'm not going to part with $80 just to have fun with it, see if it works. So somebody else can do that and give us a feedback.
Steve, with those surface mounts, how do you know which terminal is positive and which terminal is ground?
Well, that's a good point and question, because when one of those I bought doesn't tell me. If you have a multimeter, and most of you, if you don't have a multimeter as a motor railroader, you ought to buy one. Okay, they're one of the most. And on your multimeters, there's a symbol looks like an arrow with a line on it, and you just turn it down to there, put your positive on one of the terminals, and which is probably a red lead, and you put the other one on the other terminal. If it's beep, and if then where the red one is, that's your positive symbol. Okay.
Hey, Steve.
Yeah.
This is Roger. I just wanted to point out a couple sources for LEDs. You had mentioned a couple yourself, but I don't know if I get this up here or not. I don't know if that's probably not. It looks like it's almost too bright to see. I think that would work a little bit better. These are warm white LEDs. This is a let's see, 3 millimeter, and it has the nice thing about these particular ones is they have the resistors built in, and actually I think it has a resistor and a bridge rectifier, so you don't even have to worry about the wiring in your own resistors. And let's see, I found another source. Are you familiar with it's called Lighthouse LEDs? This is a place out in Seattle, and now I've found let's see, I've got some 3 millimeter and some 5 millimeter LEDs. Now these are with the anode and cathode prongs on them, and gosh, I mean, I can get I think 50 of these for about 18 cents each. So it's really a pretty reasonable price source. Lighthouse LEDs. And then I guess you really were focusing more on buildings in this particular presentation.
Yes.
But pardon me?
Yes.
Yeah, okay. But at some point in the future, I hope we get around to talking about mounting them on into our locomotives, because that's a lot of fun, and we got some ideas there too. And by the way, thanks for your help in some of the problems I've been having lately. Appreciate it, Steve. Take care. Thank you very much.
My pleasure. Roger, talking about LED or lighting and so on.
Yeah.
I really enjoyed your presentation of Kit bashing the passenger car into a diner.
Oh yeah.
Yeah, that was well done.
Well,
But
thank you.
I couldn't help but thinking, that would really look good with the lighting in there, because you could have the
Yep.
lunch counter in the front and center,
Yep.
and I mean, it would really sparkle with putting some people in there on the lunch and at that counter and so on. So
Sure would. I'm still trying to figure out how to get the HO scale sandwiches into the diner, but that's another problem.
they don't need to do that. Don't have any customers. So
Right. Thanks. Nice presentation, Steve. Thank you.
my pleasure.
Hey, does anybody else have any questions for Steve or to add anything?
All right.
Okay, well, thanks again, Steve. Appreciate it. Very good program. That scene of your station at night, I really like that with the exterior lighting in that. That really looked nice.
Hey, Andy,
Yes.
I was just wondering if anybody has any experience with the like the optical lighting, optical cables and a light source, and
You mean fiber optics?
yeah, fiber optics.
The company that I showed you in terms of the control box for from Model Train Technology. They have a similar box for LED light or fiber optic lights as well.
Yeah.
And they sell packages on that. And then the price is about the same rate, and they have the same sort of control capabilities on those as well.
I just wonder if any of the people here on the Zoom meeting have done that at all. No? Okay.
I have not.
Go ahead, Roger.
No, I just was gonna say, I've not had any experience with that, but LEDs just seem to be so much easier to work with. Just my point of view.
Right. I bought some fiber optics, just the right size for the headlights on when I was building my GP7s up. Because I couldn't get the regular LEDs down in there, but now the surface mount LEDs, I'd much rather go with those than the fiber optics. Okay.
I've actually had some experience with the fiber optics. Long ago in a galaxy far, far away before LEDs were real common. I did doing marker lights in my hood units, and it was okay. But I mean, the fiber optics were just really difficult to work with. You bend it too far, and you lose your light, and you have to really polish the end to get any good light out. And it was, for the time it was okay, but LEDs probably are the way to go nowadays.
All fiber optics, they're all white, aren't they? I mean, they're clear, or is there actually red and green?
The fiber will pass through whatever color light you put in it. You put a light on the one end, you see it on the other end. That's the idea of a fiber optic.
Oh, I got you. Okay, so if you have a red light, then it'll come through as red at the other end of the fiber.